Okay, let's walk through some questions for exam SCS-C02, and this is about AWS security specialty. Okay, for question number one, the following are given. A company has an AWS Lambda function. The function creates image thumbnails from larger image. The Lambda function and the AWS S3 are in the same AWS account. And then you are required that the Lambda function needs to read and write access to the Amazon S3 bucket. You must choose two valid solutions to grant access. Here's the question. So question number one, a company has an AWS Lambda function that creates image thumbnail for larger image. The Lambda function needs read and write access to Amazon S3 in the same AWS account. Which solution will provide Lambda function this access? You need to choose two. Question letter A, create an IAM user that has only pragmatic access. Create a new access key pair, add environmental variables to the Lambda function with access key, ID, and a secret access key. Modify the Lambda function to use environmental variable at runtime during communication with Amazon S3. Letter B, generate an Amazon EC2 key pair. Store the private key in the AWS Secrets Manager. Modify the Lambda function to retrieve the private key from Secret Manager to use the private key during communication with Amazon S3. Letter C is to create an IAM role for the Lambda function attached on IAM policy that allows access to the S3 bucket. Letter D, create an IAM role for the Lambda function. Attach a bucket policy to the S3 bucket and allow access. Specify the function IAM role as the principal. Letter E, create a security group. Attach the security group to the Lambda function. Attach a bucket policy that allows access to the S3 bucket through the security group ID. So basically, we just need we have a Lambda and we want to allow it to access S3. So basically, the correct answer is to have an IAM role that the Lambda will run on, and you will need an IAM policy for that Lambda, and you will need an S3 bucket policy. So the correct answer is C and D, right? So we create an IAM role, attach the IAM policy that allows access to S3, and that same IAM role, we need to attach a bucket policy to the S3 bucket to allow access. So this is the standard way to grant access to AWS Lambda. And you create an execution role for the Lambda function and attach it to IAM policy that allows role to automatically assume by the Lambda following during execution. You you can also attach bucket policy directly to the S3 bucket. This policy this policy specifies the Lambda function IAM role as the principal in granting it access. Question number two. The given a security engineer is configuring a new website, which is example.com. The goal is to secure the communication with the website, and user must connect via HTTPS. You are required a valid option for storing the SSL TLS certificate to enable HTTPS. So this is the question. A security engineer is configuring a new website that is named example.com. The security engineer wants to secure communication with the website by requiring user to connect to example.com through HTTPS. Which of the following is a valid option for storing SSL certificate? Letter A, custom SSL certificate is stored in AWS Key Management Service. Letter B, default SSL certificate stored in Amazon CloudFront. Letter C is custom SSL certificate that is stored in AWS Certificate. And letter D is SSL certificate that is stored in Amazon S3. So the correct answer is letter C. AWS SSL certificate that is stored in the AWS Certificate Manager. or ACM. So we store the ACM directly into the we store the certificate directly into the ACM. So AWS Certificate Manager is designed specifically to manage LTLS certificate for AWS services. You can import custom certificate or request free public certificate for domains like sample.com. ACM integrates seamlessly with these services, elastic load balancing, CloudFront API gateway, and elastic beanstalk. The following options are wrong. KMS is for encryption key, not SSL. And default SSL in the CloudFront provides a default certificate but not for custom domain. And Amazon S3 is an object store, but it's not used for storing certificate. You can install a certificate, but it's not usable for SSL termination or HTTPS termination. Question number 3. So the company uses Amazon EC2 instances backed by Amazon EBS. All EC2 instances are managed by AWS System Manager. SMS agent is installed on EC2 instance. A security engineer is developing a response and investigation process. And the process must follow the AWS best practice. You are required to preserve volatile memory, which is RAM, and non-volatile memory, which is the memory from the disk for forensic analysis. You need to update EC2 instance metadata with incident ticket information. You need to keep the compromised EC2 instance online but isolate it to prevent malware spread. Let number 4 is capture investigative activity logs during volatile data collection. So this is the question. A security engineer needs to develop a process to investigate and respond to potential security events on Amazon EC2 instance. All the EC2 instances are backed by Amazon Elastic Block Store or Amazon EBS. The company uses an AWS System Manager to manage all EC2 instances and has installed System Manager agent on all EC2 instances. The process that the security engineer is developing must comply with the AWS best practice and must meet the following requirement. A compromised EC2 instance volatile memory and non-volatile memory must be preserved for forensic purposes. A compromised EC2 instance metadata must be updated with corresponding incident ticket information. A compromised EC2 instance must remain online during investigation but must be isolated to prevent spread of malware. Any investigation activity during collection of volatile data must be captured as a part of the process. Which combination of steps should the security engineer take to meet the requirement with the least operational overhead? You need to choose 3. Letter A, gather any relevant metadata that the compromised EC2 instance. Enable termination protection. Isolate the instance by updating the instance security group to restrict access. Detach the instance from any auto-scaling group that the instance is a member of. Register the instance from the elastic load balancing resources. Letter B, gather any relevant metadata from compromised EC2 instance. Enable termination protection. Move the instance to an isolation subnet that denies all resources and destination traffic. Associate the instance with the subnet to restrict the access. Detach the instance from auto-scaling group that the instance is a member of and deregister the instance from any elastic load balancing resources. Letter C is use the system manager run command to invoke script to collect volatile data. Letter D is establish a Linux SSH or Windows RDP or remote desktop protocol session to the compromised EC2 instance to invoke the script to collect volatile data. Letter E, create a snapshot of the compromised EC2 instance, EBS volume for the follow-up investigation. Tag the instance with any relevant metadata and incident ticket information. F, create a system manager state manager association to generate the EBS volume snapshot of the compromised EC2 instance. Tag the instance with any relevant metadata and incident ticket information. Correct answer A, C, and D. The correct answer A, C, and E: gather metadata and enable termination protection, isolate by a security group, detach from the auto-scaling and ELB, use system manager run command to collect volatile data and create a snapshot of EBS volume, and tag the incident metadata. So letter A allows metadata gathering, tracks the incident, and support forensic documentation. Termination protection prevents accidental deletion. Security group isolation is lightweight and avoids downtime. Detaching from auto-scaling group and ELB prevents reinfection or traffic routing. Volatile data collection via SSM is using system manager to run command allows secure, auditable script execution. No need for SSH or RDP, which could expose the instance further. It also captures the investigative activity as part of the system manager logs. Question number 4. For this, here are the given. This AWS organization is in use. The company operates with multiple AWS accounts under centralized organization. CloudFormation stock sets are being used. Infrastructure pattern EC2, LB, RDS, EKS, ECS are deployed across environment via stock set. Developer has autonomy. They can create their own CloudFormation stack to accelerate their delivery. Centralized CI/CD pipeline located on a shared services AWS account, responsible for deploying the CloudFormation stack. Security team has defined standards, which are internal compliance requirements exist for all AWS resources that must be enforced across all deployment. And security team must be notified if any resource violates internal standards. They need to be alerted. The solution must not slow down developer. You are required to implement a security validation process for CloudFormation template before deployment. Integrate this validation into CI/CD pipeline and ensure the notifications are sent to the security team if issues are found. Use AWS native tool and services to automate and enforce the template compliance. So basically, here's the question. It's a very long one. A company has an organization in AWS organization. The company wants to use AWS CloudFormation stock sets in the organization to deploy various AWS design pattern into environment. This pattern consists Amazon EC2 instances, Elastic Load Balancing, Load Balancer, Amazon RDS Database, Elastic Kubernetes Services Clusters, and Amazon Elastic Container Services Cluster. Currently, the company developers can create their own CloudFormation stack set to increase the overall speed of delivery. A centralized CI/CD pipeline in a shared services AWS account deploy each CloudFormation stack. The company security team has already provided requirements for each service in accordance with internal standard. There are any resources that do not comply with internal standard, the security team must receive notification to take appropriate action. The security team must implement a notification solution that gives developer the ability to maintain the system overall delivery speed that they currently have. Which solution will meet this requirement in the most operational efficient way? Letter A, create an Amazon simple notification services topic. Subscribe the security team email address to the SNS. Create a custom AWS Lambda function that will run the AWS CloudFormation validate template. AWS CLI command and on all CloudFormation templates before the build stage and CI/CD pipelines. Configure the CI/CD pipeline to publish a notification to the SNS topic if any issues are found. Letter B, create an Amazon SNS simple notification service topic. Subscribe the security team's email address to the SNS. Create the custom rule in the CloudFormation guard for each resources configuration. In the CI/CD pipeline, before the build stage, configure a Docker image to run the cfn guard command on the CloudFormation template. Configure the CI/CD pipeline to publish the notification to the SNS topic if any issues are found. Create create an Amazon simple notification service topic and Amazon Simple Queue service queue. Subscribe the security team email address to the SNS topic. Create an Amazon S3 bucket in the shared services AWS account. Include the event notification to publish to the SQS when the objects are added to the S3 bucket. Require the developer to put their CloudFormation template in the S3 bucket. Launch the EC2 instance that automatically scale based on the SQS queue depth. Configure the EC2 instance to use CloudFormation Guard to scan the template and deploy the template if there are no issues. Configure the CI/CD pipeline to publish a notification to the SNS topic if any issues are found. Later, they create a centralized CloudFormation stock set that includes a standard set of resources that the developer can deploy in each AWS account. Configure each CloudFormation template to meet the security requirement and for any new resources or configuration, update the CloudFormation template and send the template to the security team for review. When the review is complete, add the new CloudFormation stack to the repository for the developers to use. So basically, the correct answer is B. Create an Amazon SNS topic and use CloudFormation Guard in the CI/CD pipeline to enforce security rules and notify the security team. Why B is the best fit? Cloud security compliance via CFN Guard. So CloudFormation Guard allows security team to define custom rules for resource configuration such as EC2 instance type, encryption setting, and IAM policy. These rules are enforced before deployment, ensuring templates comply with internal standard. CI/CD integration. Developers can continue using centralized CI/CD pipeline without delay. The pipeline runs in Docker container, validating templates quickly and efficiently. It has an automated notification if a template validates, the pipeline publishes to an SNS topic and the security team is alerted. The other are wrong because letter A, validate templates only checks syntax, not security compliance. It won't catch misconfigured resources or policy violation. Involve S3, SQS, EC2, auto-scaling, and manual template uploads add significant operational overhead and complexity. Letter D requires manual review and allows downtime delivery. And developers loses the autonomy and speed, violating one of the core requirements. So again, the correct answer is B. Create an Amazon simple notification service topic. Subscribe the security team email address to the SNS. Create custom rules in the CloudFormation Guard for each resource configuration. In the CI/CD pipeline before the build stage, configure a Docker image to run the CFN Guard on the CloudFormation template. Configure the CI/CD pipeline to publish a notification to the SNS topic if any issues are found. Question number 5. You need to choose two. These are the requirements. Company is migrating one of its legacy system from an on-premise data center to AWS. The application server will run on AWS, but the database must remain in an on-premise data center for compliance reasons. The database is sensitive to network latency. Additionally, the data that travels between the on-premise data center and AWS must have an IPsec encryption. Which combination of AWS solution meet this requirement? Choose two. Letter A, AWS site-to-site VPN. Letter B, AWS Direct Connect. Letter C, AWS VPN Cloud Hub. BPC peering for letter D, not gateway for letter E. The correct answer is A and B. The correct AWS site-to-site VPN and direct connect. Site-to-site VPN provides IPsec encryption which satisfies the requirement for secure data. Establish a secure tunnel between AWS and on-prem data center. Can be used standalone or as a backup to direct connect. Direct Connect offers low latency, high bandwidth, dedicated connectivity between AWS and an on-prem data center, ideal for latency-sensitive applications like your legacy database. Can be paired with site-to-site VPN for encryption. The other options are wrong. Cloud Hub is designed for connecting multiple remote sites via VPN, not for single on-premise data center. VPC peering only connects VPC with AWS, not AWS and on-prem. And not gateways used for outbound internet access from the private subnet, not for secure low latency communication with an on-prem system. Question number 6. The company used a dozen of Amazon DynamoDB tables to store application data. Auditor discovered non-compliance with the company's data protection policy. The company has a retention policy that mandates backup twice per month, midnight on the 15th and midnight on the 25th. Retention period is 3 months for each backup. What is required to meet the company's compliance retention policy? The security engineer must automate backup of all DynamoDB tables, triggered twice monthly at a specific time, ensure that the backup are retained for 3 months, use AWS native tools that minimize the operational overhead and align with best practice, apply the solution across dozens of tables, ideally with centralized control. So here is the question. A company has an application that uses dozens of Amazon DynamoDB tables to store data, and auditors find that the table do not comply with the company's data protection policy. The company's retention policy states that all data must be backed up twice each month, once at midnight on the 15th of the month and again on midnight on the 25th of the month. The company must retain the backup for 3 months. Which combination of steps should a security engineer must take to meet the requirement? You need to choose two. Letter A, use Dynamo on-demand backup capability to create a backup plan. Configure the lifecycle policy to expire the backup after 3 months. Letter B, use AWS DataSync to create a backup plan and the backup rule to include retention period for 3 months. Letter C, use AWS backup to create a backup plan. Add a backup rule that includes retention period of 3 months. Letter D, set the backup frequency by using a cron schedule expression. Assign each DynamoDB table to the backup plan. Letter E, set the backup frequency by using a state rate schedule expression. Assign each DynamoDB table to the backup plan. So the correct answer is C and D. AWS backup to create use AWS backup to create a backup plan, add a backup rule that includes a retention of 3 months per period, and set the backup frequency by using cron schedule expression. Assign each DynamoDB table to the backup plan. Why this work? AWS plus retention rule. So AWS backup supports DynamoDB as a native resource. You can define a backup plan which rules for frequency, retention, and lifecycle. Setting a 3-month retention to ensure compliance with the company's data protection. Those are the things that you can do with AWS backup plus the retention rule. Letter D, cron schedule for precise timing. Requirement is twice monthly at midnight on the 15th and 25th. A cron expression allows exact scheduling. Example, triggers at 12 a.m. UTC and on the 15th of and 25th of each month. You can assign multiple DynamoDB tables to this plan, ensuring consistent coverage. So let's go back to the question again. The correct answer for this one is C and D. Set the backup frequency by using a cron schedule expression. Assign each DynamoDB table to the backup plan. And C, use backup to create a backup plan, AWS backup to create a backup plan, and a backup rule that includes a retention of 3 months. Question number 7. In question number 7, you will be the following are given. The company has an AWS organization with all features activated. AWS IAM data center SSO is already enabled. The goal is to implement multi-action authentication and authorization. The solution must meet scalable, use native AWS feature, avoid user-managed infrastructure, no custom server or external identity provider. What is required? To complete the setup, the security engineer must create the user in groups for employee who need access to AWS account, assign access permission based on the job role and responsibility. Link user and group to AWS account using permission set. Ensure that employee can log in via centralized portal and maintain scalability and simplicity. No other architectural components. So here's the question. A company needs a security engineer to implement a scalable solution for multi-account authentication and authorization. The solution should not introduce additional user-managed architecture component. Native AWS features should be used as much as possible. The security engineer has set up AWS organization with all the features activated. And AWS IAM Identity Center for AWS Single Sign-On enabled. Which additional steps should the security engineer take to complete the task? Letter A. Use AD connector to create users and group for all employees that require access to AWS account. Assign AD connector group to AWS account and link to the IAM roles in accordance with the employee job function and access requirement. Instruct employee to access AWS account by using the AWS directory service user portal. Letter B. Use an IAM Identity Center default directory to create user and group for all employees that require access to the AWS account. Assign group to AWS account and link to permission set in accordance with employee's job function and access requirement. Instruct the employees to access AWS account by using IAM Identity Center Users Portal. Letter C. Use an IAM Identity Center default directory to create users and group for all employees that require access to AWS account. Link IAM Identity Center group to the IAM user present in all accounts to inherit the existing permission. Instruct employee to access AWS account by using the IAM Identity Center user portal. Letter D. Use AWS service for Microsoft Active Directory to create users and group for all employees that require access to the AWS account. Enable AWS management console access in the created directory and specify IAM Center as a source of information for integrated accounts and permission set. Instruct employee to access AWS account by using AWS Directory Service User Portal. So answers A and C uses the Active Directory from Windows, so that should not be the answer. So the answer is either B or C. And the correct answer is letter B. Use IAM Identity Center default directory to create users and groups for all employees that require access to AWS account. Assign groups to AWS account and link to permission set in accordance with the employee's job function and access requirement. Instruct the employee to access AWS account by using IAM Identity Center. So this is using the native AWS features only, no external identity provider or user managed feature. It leverages an IAM Identity Center default directory which is fully managed by AWS. Supports group-based access control via permission set which map to IAM roles, targets in the target account. It provides scalable and centralized solution for multi-account access. It aligns with the AWS best practice for multi-account governance under AWS organization. The others are incorrect. So letter A uses a connector which requires on-prem Active Directory and violates the new user managed component requirement. Letter C tries to link IAM identity center groups to IAM user, which is not supported or scalable integration. User AWS manage Microsoft uses AWS manage Microsoft AD, which introduce additional infrastructure, again not allowed per the requirement. So let's go back to that. So this is the correct answer. Link IAM identity center group is not supported. So you need to assign group to AWS account, not link. Question number 8. For question number 8, a company has Amazon Guard Duty deployed. The company wants to automate threat response. Initial focus is on RDP brute force attack originating from an Amazon EC2 instance. The goal is to block the communication from the suspicious EC2 instance. The block must remain until investigation and remediation are complete. To meet the company's goal and security engineer, which is your requirement, you should detect the guard duty findings related to RDP brute force attack, automate the response using AWS native services, block network communication from suspicious EC2 instance, preserve the instance for investigation, no termination, or disruption. Send the notification to the security team for awareness. That's your requirement, so you don't terminate. A company has deployed Amazon Guard Duty and now wants to implement automation for potential threat. The company has decided to start with RDP brute force attack that originate from Amazon EC2 instance in the company's AWS environment. A security engineer needs to implement a solution that blocks the detected communication from a suspicious instance until investigation and potential remediation can occur. Which solution will meet this requirement? Letter A, configure guard duty to send event to Amazon Kinesis data stream. Process the event with Amazon Kinesis data analytics for Apache Flink application that sends a notification to the company through Amazon SNS. Add rules to the network ACL to block the traffic to and from the suspicious instance. Configure guard duty to send an event to an event bridge. Deploy AWS WAP, Web ACL, process the event with AWS Lambda that sends notification to the company through SNS and Web ACL rule to block the traffic to and from the suspicious instance. Letter C, enable AWS Security Hub to ingest guard duty findings and send it to Amazon Event Bridge. Deploy AWS Network Firewall. Process the event with AWS Lambda function that adds rule to the network firewall policy to block the traffic to and from the suspicious instance. Enable AWS Security Hub to ingest guard duty findings. Configure an Amazon Kinesis data stream as an event destination for Security Hub. Process the event with AWS Lambda function that replace the security group of suspicious instance with security group that does not allow any connection. So Kinesis is used for streaming, right? So I think we will be using Kinesis for this one. The correct answer is C. Oh, we're not using Amazon Kinesis for this one. Enable AWS Security Hub to ingest guard duty findings and send the event to an Amazon event bridge. Deploy AWS Network Firewall. Process the event with an AWS Lambda function that adds rule to the network firewall policy to block traffic to and from the suspicious instance. Why? AWS native AWS Guard Duty Security Hub, Event Bridge, and Lambda Network Firewall. It blocks traffic without terminating or modifying the EC2 instance directly. It allows investigation and remediation while maintaining isolation. It sends notification to the event bridge and triggers Lambda integration. Letter A uses Flink and ACL, adds complexity to the subnet level control. It's not ideal for isolation. Letter B, WAP is for web traffic only, not RDP and EC2. And letter D replaces the security group, which is disruptive and risk-breaking access to or visibility. Letter C is correct. Enable security hub to ingest guard duty findings and send to Amazon event bridge. Deploy AWS firewall. Process the event with an AWS Lambda function and adds rule to the network. Firewall policy to block the traffic to and from the suspicious instance. So, Kinesis will not be used for this. According to it adds complexity. That's why letter A is wrong. And letter D replaces security group, which is the disruptive and risk-breaking access or visibility. It's going to replace the security group. That's being used by the... Okay, so the question... Okay, that's for question number 8. Question number 9. A company has an AWS account that hosts production application. The company received an email notification that Amazon Guard Duty has detected an impact a IAM user anomalous behavior finding in the account. Security engineer need to run the investigation playbook for the security incident and must collect and analyze the information without affecting the application. Which solution will meet this requirement most quickly? Letter A, log into the AWS account by using the read-only credential. Review guard duty findings for details about IAM credential. That were used, use the IAM console to add and deny all the policy that IAM to the IAM principal. Log into AWS account using read-only credential. Review guard duty findings to determine which API calls initiated a finding. Use Amazon Detective to review the API calls in context. Letter C. Log into the AWS account by using administrator credential. Review the guard duty finding for details about IAM credential that were used. Use the IAM console to add a deny policy to the IAM principal. Log into the AWS account by using read-only credential. Review the guard duty findings to determine which API calls initiated a finding. Use AWS CloudTrail Insight and AWS CloudTrail Lake to review the API calls. It's all of them is using guard duty, but you have to find except that letter D is using the CloudTrail and CloudTrail Lake. So what is given? The company has an AWS account hosting a production application. Guard duty has detect an anomalous behavior finding. The company received an email notification about the threat. Security engineer must now run investigation playbook. Investigate the IAM anomaly without disrupting the production application. Collect and analyze information quickly. Use read-only access to avoid unintended changes. Review guard duty finding and correlate with API activity. Use AWS native tool to visualize and contextualize the behavior. Visualize. So, which one has visualize here? My guess is letter D. CloudTrail Insight. That's the keyword, visualize, right? Collect and analyze is in the question. So letter D is the correct answer. No, it's not. Letter B is the correct answer. Log in with read-only credential, review guard duty finding, and use Amazon Detective to analyze API calls. Why B is the best? It's read-only access, no disruption. Amazon Detective provides visual context. Okay. Amazon Detective provides visual context, timelines, and relationship around suspicious activity. Amazon Detective provides visual context, timeline, and relationship. Fastest path to deep insight without affecting application. Deny all policies the right action that risk disrupting the production. CloudTrail tool requires setup and querying, making slower than Detective. Okay, so I was right. It does visualize, letter D does visualize, but it's much slower than Amazon Detective. Admin access and policy changes violate the non-disruption requirement. So Amazon Detective is faster than CloudTrail. And Amazon Detective has visual context. Last question. Company A and Company B each have their own AWS account. Company B stores file in Amazon S3 bucket. A user from account A needs full access to that bucket. IAM permission has been adjusted in account A, but access is still failed. You need to resolve this issue. The engineer must enable cross-account access from account A to S3 bucket in account B. Ensure that the bucket itself allows access to the external IAM principal. Use native S3 access control mechanism that support cross-account permission. Avoid relying solely on IAM policy in account A. There's not sufficient permission on the bucket side. There are not sufficient permission without permission on the bucket side. So the question is, Company A has an AWS account that is named account A. Company A recently acquired Company B, which has an AWS account that is named account B. Company B stores its file in Amazon S3 bucket. The administrator need to give user from account A full access to S3 bucket in account B. After the administrator adjusts the IAM permission for account A to access the S3 bucket in account B, the user still cannot access any files in the S3 bucket without. Which solution will resolve this issue? Okay, so we have two companies. We already grant access to IAM and A, right? Letter A, in account B, create a bucket ACL to allow user from account A to access the S3 bucket in account B. Letter B, in account B, create an object ACL to allow the user from account A to access all objects in S3 bucket in account B. In account B, create a bucket policy to allow the user from account B to access S3 bucket in account B. Letter D, in account B, create a user policy to allow the user from account A to access S3 in account B. It's all account B action. We need to create either an object policy or a bucket policy. Create a bucket ACL, yeah, access control list. What do we we're going to create or an ACL or a policy. I'm going to create bucket policy for the S3, which is letter C, I think. Okay, in account B, create a bucket policy that explicitly allows the user from account A to access S3 bucket. IAM permission in account A define what the user is allowed to do, but they don't grant access to the resource in account B unless account B bucket policy explicitly allows it. A bucket policy in account B as a resource-based policy allows the IAM user from account A to access the bucket and its content. This is a standard AWS approach for a cross-account S3 access, secure, scalable, and native. Why the others are wrong? Bakit ACL are legacy and limited, don't support full cross-account access? Object ACL only apply to individual object, not scalable or sufficient. User policy in account B can grant access to user from account A. So I am correct. And that's all for now, and thank you for watching.